10:03, I'm late already. Okay. All right, is everyone ready to roll?
Yes.
All right. Thank you all for having me. I'm Andrew Donoho. For Python conference, I think this is a kind of a stretch. We're taking the Apple Swift programming language, which is quite new. And the very first thing that I noticed when I saw it was, oh, this looks a lot like Python, except it's has types and it's really fast. And I was like, oh, and it does all this nice iOS stuff. I said, I bet my Python buddies would like to know about this. And at the Austin Python user group, I said, does anybody want a talk on this? And half the room raised their hands. Because developers like fun platforms or they believe in Python. Oh. How about this? Try to switch. How now? How now? Yay. Okay, thank you. All right, so is there another switch here? Is there a volume? Oh, down the shirt. How now? Yay. Okay, thank you all. What we noticed is everyone wanted to see about Swift, and so I put together this talk, and then I said, well, why not send it to PyTexas? If Austin people like it, Texas people might like it too. And you all are here. Thank you for coming. So we're going to talk a bit. You need to know a little bit about me, and then we're going to do, for me, an experiment. We're going to actually look at Swift in what's called a Swift playground. You can think of this as an IPython notebook for Swift. And then we're going to look at native code for an iOS app, a very simple iOS app, so you get to see the difference from just the language versus an app that actually uses the Cocoa framework. And they're very different beasts. Okay? And so both of which we have to understand if we're going to write iOS or OS X applications. So a bit about me. If anyone knows me, they know I always have a Texas hat on. We're here in the Memorial Student Center. I can't wear hats, so you get to see my hat. Okay. 5-year iOS developer, 30-year Mac developer. I make a lot of my money doing big data analysis with Python, so I use Python in anger. I teach at the Austin Community College beginning iPhone programming class. If you want to scapegoat me for things, you can blame me for SVG 1.0, XHTML 1.0, 1.1, the universal plug and play stuff. Mac clones, I was one of the tech leads on building Mac clones. I built my own accelerators, tokamaks, and my very first app was a scientific visualization app on an 8 megahertz 68000 called Mac Spin that spun data in real time. So I'm a graphics nuts and IO guy for a long, long time. Please don't scapegoat me about the path syntax, not my fault. I do know whose fault it is though, and he lives in Austin. I have his address, okay? So we're going to go almost immediately to the Swift Tour Playground that you can get from this very long URL, or you can use the human Google URL, okay, and type in Swift Playground, Swift programming language, and you'll get to the right place. Just so that you know what we're going to, though, let's click on it, on that URL, and see where it takes us. Okay, so it takes us here. Zoom up. So this is Apple's standard site for about the full Swift environment. And so we're at the top. Where we're going to have the playground is down here in the Swift Tour. And if you'll note, you can download this playground also at that link. Okay, so if you Google it, found it, you can get the playground and download it yourself. Now there is actually a couple of bugs in the playground, specifically because the language evolved since the playground was written, involving raw value access, which happens later in the document. Anyway, so now let's go to the playground. Here we go. Okay. So just to bring you up to speed. This is a playground set up in full screen mode. And we also have what's called the assistant editor. You can get that assistant editor on your screen by holding down the command key and hitting, or the option command key and hitting return. If you just hit command return, it hides option command and it comes in, okay? All right, so what do we have here? Well, we have text, we have lines of code which have results here on the side, okay? We have console output over here, and so we have three areas of interest: text, code, output, okay? So now let's start. So there's your hello world. Pretty straightforward. You can see there's C roots. They don't use vowels. Println. Okay. We don't need no I's or E's, right? So now let's go to the first thing that a Pythonista is going to notice is your variables. First of all, Pythonistas, you never actually say anything as mundane as var or let. You just set a symbol and you bang go into it. Well, this is really important in Swift. And the reason it's important is that it's a multi-threaded environment from the very beginning. They make no compromises for single-threaded performance. Python, which evolved as a single-threaded environment, makes lots of compromises to make single-threaded programming easy. iOS makes none of those compromises. You have to deal with this from the very beginning. And so what you have to do is determine whether your variables or your instance variables that you're working with are mutable or not. Mutability is something you specifically control. Mutability means it can be changed after it's allocated. Okay? So what is the difference here between var and let? Var means it's mutable. Let means it's a constant. It cannot be changed. Okay? This is important because you're going to be passing immutable things to other structures that end up on different threads. Part of the reason the UI is smooth on iOS devices is that things run a lot on background threads. So let's take a quick look here. So mutability means we can do things like, make that 51. Life is good, it's recalculating. But let's come down here and set my constant command complete, yes, equals 2. And notice the error we get in the upper right corner. And it says, can it assign to let value my constant? So in other words, it doesn't let me overwrite a value. And that could be something that holds an object, etc. So this constant nature is an important part of how we get to multiprocessing. Okay. Swift is strongly typed and typed checked. Python is strongly typed, but not type checked. Every object in Python has a type. You may never have to worry about that type, but it does have a type. Okay, slots don't have types. All right. So the places you put the objects are blank. In Swift, because of, for example, that implicit integer, well, it's an integer because the number 70 doesn't have a decimal point on it. And so it says this is an integer. But that is all a strongly typed statement. The double is the same case because double is the default. We could make it a float, okay? For example, we could turn this into, the type here is float, we could change that to a float, okay? Okay, it's no different, but it's now shorter precision. But the default floating type is double, just like it is in Python. Okay. So let's keep rolling. As you're used to in Python, the plus operator adds strings. Okay, so we have label plus string width converts an integer into a string in a default way and bangs it in. Okay. They have notes along the way about little tests that you can do. We're not going to do all of those. We're not reading this. I'm just blowing through it so you have familiarity. So, but this one is actually an important feature, is the nature of string interpolation. In Python, we have the format statement, or even the older school percentage formatting. The format statement is a It supports very nice indirection into objects inside the Python format statement. We actually have complete expressions, or Swift has complete expressions inside the string. Okay, so for example, this /paren then allows apples plus oranges, okay, which is a numeric number. You get 8 pieces. Okay, so now let's see what's going on over here. We click here, and we get to see the full string. We also have a thing called an observer. It's hiding there. And that's a fast, quick look. And so frequently if you have images or other things in your data structures, you can actually, it will display the image as opposed to the size of the array, etc. Quick look is a very nice feature of the Xcode 6 experience these days. All right, so let's do this. For those of you following along, I'm going to hit the Command / key, and that converts uncomments the line that the cursor's at. So comment it out, comment it in, or comment it in, yes. So now I have 0.6 pieces. Okay, so you can see the whole 0.6 apples per orange. This I expect to be a really useful characteristic during debugging. It's since professional iOS apps and OS X apps have to deal with localization. There's a whole localization scheme that you're going to have to use that this may end up proving less useful for, because you're going to have to put these strings together with numerics, so the interpolation may not be as useful unless you put all your French, German, and Japanese in your code, right? Which you don't want to do. So to your Pythonistas, you'll look at things like this array initializer and say, oh, I'm right at home, right? Square bracket, okay, I've made a list here. I numeric index into it, life is good. Oh, how do I tell that I'm doing a dictionary? Well, it's the items that are in the list that are what make it a dictionary. So that Malcolm, Captain is what makes this array, not an array, but a dictionary. Okay, it's what's in it. And this is a common pattern you'll see in Swift. What is inside the collection types it, changes what the annotation means. And so when we start talking collections in Swift, part of why collections are very fast in Swift are typed. So it knows exactly what's there. It knows how to dereference them explicitly. It doesn't do method resolution. It just goes in there and it's fast. That's part of why it's one of its big features. You can see that because this was occupations there was assigned to a var, you can now add Jane as public relations. Yeah, right. Okay. If you believe public relations are a gun. Everyone knows who Jane is? And from Serenity? Okay. He was a guy who used a big gun a lot. Okay. So here you see the initializer form. If you wanted to make something that was an empty array, and now it's kind of interesting they assigned it to a let, which means it's immutable. Okay, there is a side effect of when you assign a mutable structure to an immutable slot, it's now treated as an immutable item and is passed around as immutable. So in other words, to let us change that array, it would have had to been assigned to a var slot. Okay. So let's keep going. All right. So control flow. Control flow is kind of what you'd expect, like that if statement here. This if statement here looks, you don't see any fancy parens or other stuff that you're used to, except you see the curly braces. Swift uses curly braces. There are no semicolons. Okay. We don't need to get into the significant white space versus curly braces argument. Okay. I'm not about to go there. This is what they chose. Now the curly braces become basic blocks, which also start to get overloaded later on. You'll see in what are called closures. And closures are more fundamental than functions or methods. Everything is specialized off of closures in Swift. Okay. So there's a lot of actually syntactic shortcuts that show up in more advanced uses of the language about how we use and create closures with various elided versions of the syntax. We're not going to go into that set of elisions in this talk, but it's there. And it's all tied to how these features work together. So now we're going to get to the other interesting aspect of variables, and it's the optional construct. Variables that are defined optional have actually two states. They have nothing is there. By nothing we mean nothing, or it has a value. 0 is not the same thing as nothing. And part of the reason this is here is that Objective-C has a feature. As a feature of Objective-C is that you can send any message to a nil item and it will not crash. Try sending a message to none in Python and it just crashes. In Objective-C it doesn't crash. And so the whole programming idiom of the underlying frameworks will be frequently returning nils to demonstrate errors. But the code will just keep running. Frequently people don't bother to check errors and it doesn't crash. It just doesn't do anything. And that's frequently the right answer. But to more formalize that, because it being type safe was an important aspect of the language and of their goal, they decided to formalize this behavior so that people could declare things to be optional, so that they would have two states of invalid and something. Does that make sense? Okay. So this is kind of odd. So how do you unwrap an optional? Okay, so here we have a string declared hello up here, okay, and we basically, you can see that the next line is a Boolean test comparing it is optional equal to nil, and it's false. So now I created an optional name here, okay, and I assigned it to nil. If I come down here and uncomment this, I've now assigned it John Appleseed, and this string interpolation here, let's close this. This string interpolation here, okay, hello John Appleseed. Now if I comment this out, that goes away. So what happened here? Well, in this if statement has a side effect in that it declares a Boolean result. If this optional name is assigned to a constant, that unwraps the value. If there is a value there, it returns true, and the true branch of the if statement executes. So in other words, we unwrap the optional and we declare it to a value that isn't optional, and we can use it in the block controlled by the if. Okay. Since this happens a lot, when you start writing Objective or iOS code, you will be using optionals. Optionals are defined all over the framework. It's not a feature that you can ignore. It's part of what's built into the Cocoa framework. They did not make a new framework to support Swift. They designed a language that would be type safe that worked with the framework. This is one of the issues with Apple. Apple does things that support them and support their framework. They have no interest in porting this anywhere. If you think that someday this code is going to port to Android, never going to happen. Never going to go to servers either, unless that server is running OS X server. Okay, so don't think of this as a portable language. Think of this as a more productive language for people who are used to modern syntaxes. All right, so if you're going to go into the iOS world, you've always had to pay the technology tax of going to their frameworks, their languages. This is what you get to do. Now you can compile in, link in C, C++, Objective-C, all of those can compile into this environment. Were you asking a question? No. Okay. So it isn't as much of a restriction as you might think, but in practice, your whole portability story, you're going to a proprietary platform that's very serious about remaining proprietary. So they use a lot of open source tools, they support the open source community, but don't think that you get to make code that's going to work on any other platform. That's part of being a sharecropper in their world. Okay? So They have switch statements. The switch statement is much more powerful than traditional C and C++ switch statements. You don't have to switch on just integer or enumerated values. These can be strings, these can be objects, these can be quite complex things. So the switch statement is extremely powerful in Swift. Okay. So one of the things that you as a Pythonistas will be very happy to see is that tuples are in this language. So if we look here at this for loop, so we have a dictionary up here, a dictionary of arrays, okay? Now we see the for loop expands the items in interesting numbers into kind numbers. So that's basically you get the key and the value split out for you automatically, just like it was a dictionary.items in Python, right? So the ways you're used to thinking of things start to happen in this language. So the kinds of structures, automatic tuple expansion is happening. Okay. While loops exist, do while loops exist? If I recall, Python does not support a repeat until structure. Guido doesn't seem to like that. Here's the equivalent. Here is a do while. So if you really miss the lack of a repeat until, Swift has it for you. You can also do numeric references. So here's the equivalent of range. So 0 dot dot less than 4, which basically says everything up to 4. Or if you wanted to include the 4 there, it would be 0 dot 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 4. Okay? So that this lets you have tail inclusion or exclusion as you wish, based upon whether you're using a dot or a less than sign. Okay. You can, of course, do old school C-style loops because, well, these are all C++ guys who did this language. They show us functions first in this tour, but functions are not primary. Closures are primary, but functions put a name on a closure. Okay, so we start with a function. So instead of def, it says func. And if you use Python 3 type annotation, then this statement of name colon string comma day colon string arrow string, well, you take the ings off those strings and change the func to a def, and that's a Python 3 function annotation, annotated function. So those of you who are using Python 3 and those features, this looks like what you expect. It's extremely simple and straightforward to what you use. Let's go down to the next one, calculate statistics. And here we have, you pass in an array of ints, and you get back a tuple, min, max, and sum. Okay, but it's more than just a tuple. It's actually a named tuple. So each one of those items has a name now. It could have been just a tuple of 3 ints. You didn't have to give them names. Okay. And so as you look, as I scroll this up, sorry. As I scroll this up, you can see us talk to statistics as a calculated statistics from that array. You can get the sum, or you can access item 2. Okay. Functions can also take variable number of arguments. Those turn into a collection, which you can then access as, as you can access in a for loop in a collection processor. Okay. Functions can be nested. Well, it's because they're closures, they can be nested. They give them names. They can be returned. Okay. So here's how you type a return value. Okay. By the way, quick Python question. Does anybody know the type of a generator that's a generator function? What's returned? Well, it has a type. It's defined actually in the collections class, and it's an iterator it's an iterator object. Okay. But all of that is defined, by the way, okay, in Python. This is this statement here says, I'm going to return a function that takes an int and returns an int. Okay. When we get to the generic part, you could easily see that this could take a generic type and return a generic type. And so that generic programming could take place here. So Swift supports all of the characteristics that you get from C++ generic programming in essence. So some of the things that, for example, James Powell was talking about yesterday about doing more functional programming and allowing the generators to return dynamic types, etc. Well, Swift is going to do it differently, okay? And it's going to exploit all the other aspects of the type system. Okay, you can pass in functions as arguments. So here, this line here is passing in an int that returns a bool. Okay, all right. So functions are actually a special case of closures. And so here we're starting to see functional programming with numbers.map. So basically, we run this closure over each of the items in numbers.map. Okay, and returns the result. Okay, so if we have the numbers up here are 60, and then down here they are, see the number of times it executes. So it's changing the value as you see, up and down. So now let's start to talk about, oh, by the way, there's also temporary names, so you don't even have to declare a name. So we need a soupçon of Perl into everything, right? Soupçon. Okay. At least y'all smiled. Yay! Okay, so what is an object? An object is a class. There is no object you inherit from. It's implied, just like in original Python objects. It's an implied statement. You define vars. You can define optional vars. You can define ones that cannot be made optional. Basically, life is, it's as you would expect. An initializer, well, that initializer right there looks quite similar to what you would expect. Okay, you can have an arbitrary initializer since it dispatches on signature. You can have multiple things called init. Okay. Let's see. So here's the initializer calling the superclass. Okay. One of the next aspects you see is that they declare overriding. They force you to declare if you intend to actually override a superclass method. This allows you to keep from inadvertently subclassing something you did not intend. It also has some performance implications. If they know that the last item in the chain doesn't have anything underneath it, they can actually dispatch faster as a result of this. This is so different than the C++ way where you define things virtual at the top of the class, and that doesn't let the compiler actually know anything about how it's actually used. Whereas this lets the compiler know things about how the programmer intended, and there are some natural optimizations that come from that. And you see this sort of stuff pop up through Swift as very natural things to do that also improve the engineering quality. We've all run into code that has inadvertently subclassed a method that was named above it for totally different purposes. Right? Well, the compiler will catch that if you try to do it. Okay. Okay, I'm running out of time. This is the next thing I wanted to show you is getters and setters. So this is how you define getters and setters to this variable, which is always a property. Because iOS and OS X support this idea called key value observing, such that any object can observe any other object. The use of properties is, while not mandatory, there are ways to get around this, is strongly supported because it's an extremely common programming pattern that you will watch a single variable in another object, and when it changes, your UI will react to those changes. And it becomes a very nice, simple pattern that reduces a dramatic amount of code. You don't listen for notifications and then go do something. You tied it all up and it just happens. Right? And so being in properties, it's important. There are some other characteristics you can get called before a property is set with the value that's going to be set, and you get to see what the value is before it gets set. So you can make decisions based upon a before and after value change. So there's a bunch of nice things that happen in iOS because everything is a property. You can escape behind it if you need to, but by and large, as beginning Swift people, stick with the properties. Okay? In other words, it's the least code to write and you get properties. Okay. All right, so we are running out of time. I want to show you some real code, except I want to show you some iOS code to show you how different it is from this language thing. But this I want to show you first. This is a carryover from the Cocoa framework, this syntax. This syntax, increment by amount, so the variable name inside the method is amount, and then we've got this thing called number of times, times, and int. Well, the variable name is actually times, and the reason this is done is because Objective-C had this idea of each statement was a sentence with a subject and a verb. And so many of the methods are written such that they read as a kind of a pidgin English. And so each parameter has a name and you actually write sort of sentence-like statements. So the framework has this pattern. So to basically send the increment by message, the increment by and number of times message to counter, this is the Swift equivalent. So Swift counter.increment by 2, number of times 7. All right, so that naming is important in the Cocoa framework. All right, you start looking at named parameters in other languages, this pattern starts to emerge in Ruby and places like that also, since Python has had keyword arguments forever and ever. You've seen this kind of stuff, but there's a reason it's here and it's kind of different than what you would expect. All right, so I'm looking at my clock and it says I've got 20 minutes. I have one more important thing to show though. We have a concept called structures. Structures are like objects. They have behavior, except they cannot be subclassed. So you can make a point structure and it can have characteristics like distance and some other stuff. You can put a bunch of methods on these structures, but they cannot be subclassed, and part of that is performance. Another part of it is restriction of structures is that they are always passed by value. Objects are passed by reference. Structures are passed by value. And this gets into the whole multi-threaded multiprocessing. You want to send stuff to the other side, you throw it all in a structure, pass it over there. It all goes across the thread boundary, and it executes over there. So one of the big uses of this pass by value is to pass the things you're sending over to another thread in a structure, not by reference. Okay. So now let's go to code. So what I'm going to show you is a little app. Called Monkey Pinch. And let's Monkey Pinch is a little Swift app that is a tutorial done by these people. Okay. Before I get there, it's this dragging example. The human Google URL is UI gesture recognizer Swift tutorial. The link is here. Okay. And Ray Wenderlich and team, they just do a bunch of different interesting tutorials on how to come up the ladder. Apple's documentation is quite good. There are a lot of sample code. It's an extremely well supported documented environment with a third-party ecosystem, etc. I chose to do this code rather than write something myself is because I wanted you guys to follow these links to start to learn the ecosystem rather than come to my code. Okay? So there actually is not me being lazy. This is actually has a pedagogical purpose to go use these other people's code. It truly is that. I'm an educator. You can trust me, all right? So if you can go through here, there's a lot of stuff describing it. Let's just go into the Xcode project, though, okay? I have a few things I want to show you first, though. Every iOS app is deterministically managed memory. We haven't talked about memory management, but I'm going to give you the very fast 2-minute tour of memory management. We're also going to talk about that everything's multi-threaded. I've mentioned it a lot. It's a very real issue that you're going to have to consider once you start making complex apps. You're going to have to start pushing stuff off the background thread to keep the UI live. It's extremely important. It's easy for people to see. This is old school MVC, as a la Smalltalk MVC, tightly bound model view controller interactions with observers, etc. The MVC that is bastardized by the web community is really what I call a partitioned MVC, where on your server you have a model and a controller, and on your web browser you have a view and a controller, and those controllers talk to each other, but your view doesn't talk. So it's a partition thing. This is not that. This is extremely tightly bound MVC. So let's talk about memory management. How does it work? It's magic, okay? Just like you think about garbage collection on Python, when is all the garbage collected? No one really knows. In iOS, because we do not have a backing store, we have to know exactly when that memory is collected. But we don't want to put the bookkeeping on the language or on the programmer. Older school Objective-C, a lot of bookkeeping had to happen on the programmer, and the memory system underneath iOS is still called manual retain release. That code is still down there. One of the big innovations in Objective-C was automatic reference counting. So the compiler started taking care of things. Swift takes this to an extreme, but you as programming on iOS, you gotta know what's happening. You don't have to do anything though. So it's magic. And so objects are added to a pool, and that pool is going to be drained at some time in the future. So your garbage is going to be collected at some determined time in the future and in a batch. It's not going to be some careful process that asynchronously gets in the way of your precious UI. Okay, so let's watch it. Now this is the basic app architecture you've come to know and love. You launch the app, initialize it, you load the main view, and then you start waiting for events. Events are things from networks, mouse touches, that sort of stuff. You start waiting for them. Okay? And so every time you allocate some memory, you start going around the loop, you allocate it, it gets put in the pool, you do some more things, and then as you get back to the top of the loop, everything gets released. By the way, in this bottom part of the loop, Apple's coordinating all the GPUs, all of the radios, all of the networking stack. There's a whole bunch of stuff that goes on here. And so the reason you want to get your computation off of the main event loop is you want Apple to have time to coordinate stuff. They don't actually do the work there, but the main event loop is the heartbeat of every app. And it needs to run probably 120 to 200 times a second to actually keep everything smooth. And so this is what happens in iOS. You're going to be throwing your code that does actually real work off to the future, and then you're going to take the result and you're going to put it back on the main loop for presentation in the UI. All right, so this loop architecture is very important. Python, which did not have a loop architecture until Python 3.4 with async I/O, many people don't even understand what event programming is. We've had talks here about Tornado and other things, and async I/O, and it's new to a lot of us Python programmers. Okay, you have a loop. You only have one loop. You actually use Apple's implementation. Okay, you go into the pool, things will go away, and you're done. Okay, one last thing is not garbage collection. Garbage collection, you don't know when it's going to happen. We know every time you return all the way back up to the framework, that pool is going to be released. If you have a lot of work that you're doing that has a lot of transient stuff, you can actually create your own pools and release them and control that in your app. But every time you're called into your code, that pool happens. That pool is created and drained. That's very important when you don't have a backing store. Okay. So now let's go to the dragging example. I've got 12 minutes and 39 seconds. Okay, so let's run it. Am I running? So I hit Command R, device locked. Oh. Okay, sorry. The reason I'm running this on the device is that there are things that the simulator makes hard. I just wanted to show you that the app actually does this before we dig in. So we can move the monkey around, we can pinch him, we can twist him, we can do these things, and it's harder to, you can't do the twisting and the zooming necessarily on the simulator. Okay, You can have it make noise, basically eat the banana. Okay, move the banana around. Okay, so fundamentally it's a fun little app that just does a little bit of I/O. And the devices do more than the simulator. We're now going to move back to the simulator. Okay. And I do that by dropping down what device, and then we got a bunch of simulators for iOS 7 and 8. That was the 4S. Let's do it on 8.1. Let's run. Okay, same app, same thing. Yeah, you can make the noise here. So, okay, so now let's take a quick look at what an app looks like in iOS. Okay, so first thing, we're in Xcode 6. The left-hand side is a sort of project browser. Okay, let's zoom in. I'm sorry, it's small. Let's zoom in. This is sort of a project browser. You can see in this app called Monkey Pinch, it has a project area called Monkey Pinch that has what's called the app delegate and the main view controller and Tickle and some other gesture recognizers, some assets, the 1 and 2x assets, some audio files, these CAF files, and other supporting stuff. Okay, so let's back down. One of the things you do, what I do all the time is just to show you, okay, let's go ahead and close it there too. One of the first things I do is I always set a debugger at the very first instruction. So here's the very first place you get called. So if I run, here we go, and we are now, this is entering the main event loop part. You saw in that drawing where you enter it's called application did finish launching with options. So fundamentally you get past what's called the delegate pattern, which is the thing calling you, and what they want to do. So this is a 2-parameter thing. You can always then easily talk to whatever called you. So since typically these are delegate protocols, you don't actually know what it is. You don't know the class of what it is. It implements typically, your protocol is all you know. Okay. So I always hit the breakpoint. You saw how hard or easy it was. You basically click on it just like every other interactive debugger. So I've got 9 minutes. So now I hit Command-Control-Y for it to run on, and here's the app. Okay, we can do things like this. So now let's go into what's called the view controller. And the view controller has a place. So here are the key variables of the view controller. It's what's called a pan gesture recognizer for both the monkey and the banana. So basically, that's an Apple routine that's going to measure whether you touch it and then start to move. Because you can just touch and hold and you're not panning, because you may pick your finger off and that may be considered a tap, though there's a time basis for that. So there's a whole set of complex gestures that Apple has codified that are very easy for you to sign up for, and you get called when the Apple environment declares that thinks something has been a view. So it's very easy to do pinches and zooms and twists, etc., because Apple does all the hard work, and they just call you to do whatever it is your app is going to do as a result of that event. Right? So here are the variables. Okay, so you see an IB outlet, that stands for Interface Builder Outlet, which is a variable you can access. It's called Monkey Pan. It's a UI pan gesture recognizer, and it has that bang at the end. What's that bang? All right, that bang means this is a dangerous thing. All right, danger, Will Robinson. It may be valid, it may be not. It's not optional. Typically, it's a weak value, so it almost certainly executes the nil method aspect. That still is available in Swift. You do in Objective-C, you send a message to nil, it doesn't crash. Typically, what that means is it's not using the Swift optional mechanisms, it's using the old Objective-C optional mechanisms. And since this is something from Interface Builder that has to work in both worlds, it can't use the Swift stuff. So that just means danger, Will Robinson. This is not under deep control of the Swift environment. Okay. So the IB outlets, these are things that connect you to the graphic environment. Here are two audio players. Notice that they are optional and they're set initialized to nil. Okay. So interface builder talks to the monkey pan and banana pan, but does not talk to chomp player and hey hey player. Okay, and that's the big difference there. So the first place you go in an iOS app is, and you're loading a view, it's called Viewdidload. So you get called after the view has been read in from the storyboard and executed, and so this is the first place you get to look at things. So one of the first things this author did was go to the view, find the subviews, and then filter them, okay, by passing in this one-line closure. It looks a lot like a lambda, right? So $0 is passed in. Is it a kind of class image view? So I'm basically filtering all the views in the ViewController's view to find the image views. And I get back an array of filtered subviews, all of which are guaranteed to be just image views, i.e. the monkey and the banana. Okay, so here we're showing functional programming, higher order programming. You're passing in a lambda. Life is good. You know, when you think of it as a lambda, you know exactly what this is, right? We do the filtering, and then now we're going through the views and filter subviews. We're creating tap gestures, so you can tap on it and make it laugh. You can't do a tap unless you make things fail, so you have to tell the recognizer that you're not panning. So panning has to fail for a tap to work. Okay. And so here we are also loading the sound. Okay, so basically Viewdidload starts to tie all the pieces together. And so if you look at this code, there's actually very little of it that looks like Swift. You know, think back to what we saw in the playground. Okay, and so the big message I want to leave with you is that, yes, you lost a lot of syntactic noise moving to Swift. You still have to learn the iOS Cocoa and Cocoa Touch frameworks. And these, we're talking 25 to 30,000 method calls in this set of APIs. If you think the Python standard library is a big deal, it ain't nothing compared to what's going on in the full Cocoa framework. If you think about the video systems, the audio systems, the mapping system, the table view system, I can go on and on and on and on, and Apple has lots of documentation that covers it. And so what this has done, though, has reduced a lot of syntactic noise, which will make it easier for you and make it faster. Oh, don't look so ugly about this. He's sneering. Okay. But this doesn't get changed. Swift doesn't solve that problem. You have to learn the framework to actually use it. That said, it's a fun framework. So if you're looking at this as something to do on the weekend for fun, it's a great fun platform that's not Python, right? So you can actually get a headspace relief from Python, and you'll have a fun platform to work on, okay? I think I'm out of time. If I want to answer any questions, let me put up my last foil. And summary, Swift is ready for new work. iOS is your challenge. This is me. You can start searching for things like We Heart Swift and stuff like that. These links are, I'm going to make all these foils available to everybody, but you got the basic Google URLs anyway. Any questions, because I'm out of time? Yes?
So you mentioned that all of these frameworks were obviously written in Objective-C. Do you still suggest people learn Objective-C, or is it okay to learn Swift and start writing?
I'm doing that experiment right now with my students at ACC. I have a few that are just learning Swift. You will have to learn to read Objective-C, but reading is different than writing. Okay, you have to know Objective-C. All of the documentation has them both. But yes, if what you're talking about is doing something that you expect to ship in, well, you can ship 1.0 apps right now. But if you expect to ship sometime in the next 3 months to 9 months, go for it if it's your own personal stuff. If you're trying to build a consulting practice, you really are still going to have to know how to write Objective-C. Okay, sir?
Can you just play around and write your own apps for your own iPhone, or own iPad, and not have to mess with the distribution mechanisms or stores or qualification?
Well, Apple requires that you give them the $100 so that you can load on your devices. Okay, and that's because you actually get a tech support entrant. It's actually get 2 per year for that $100. So you can actually ask Apple questions for that $100. So it's not just pointless. There is value. Okay.
$100 every year.
It's $100 every year. Any other questions? I think I'm out of time. All right. Thank you all very much. All right.